friends, today TK is here to explain few identities from exercise 11.1 of O-level Maths book. So first of all, let me go through few identities which are given in the paper or which you use to prove the identities given in the exercise. So number one is tan theta equals to sin theta over cos theta. Number two, sin squared theta plus cos squared theta equals to 1. And you need to learn these by heart, and when you do few identities, automatically you learn them. 1 plus tan squared theta equals to sec squared theta, and 1 plus cot squared theta equals to cosec squared theta. Now cot theta equals to cos theta plus sin theta, or 1 over tan theta. Two more, sec theta equals to 1 over cos theta, and cosec theta equals to 1 over sin theta, right? So now let's solve few identities from exercise, and we will see how does it work. Okay, so this is question number 9 of exercise 11.1. 1 minus 2 sin square x is identical to 2 cos square x minus 1. Now this is an identity symbol when you draw three parallel lines, small ones, right? Okay. Now when you're solving identities, it's up to you. You want to pick up left hand side of the identity or the right hand side of the identity. And then you keep simplifying it, simplifying it so that it takes the shape or it takes the form of the other side. So if you are solving or taking left hand side, it should turn out to be right hand side, or if you are taking right hand side, it should turn out to be left hand side. So let's take here left hand side here. 1 minus 2 sin square x. So which identity I can apply here from the one I have just shown you? It is 1 minus cos square x in place of sin square x. You know why? Because we have seen the identity sin square theta plus cos square theta equals to 1. So if I manipulate it and make sin square theta a subject, it will be 1 minus cos square theta. So this is what I am doing here. I am substituting here the value of or the identity of sin square x. Then algebraically I am removing the brackets, and it will give me 2 cos square x minus 1, which is like right hand side. So I have proved here the identity. Now let's see question number 12, which is sin x over cosec x minus cot equals to 1 plus cos x. So again I will take left hand side here, and then I will try to simplify it. So in place of cot x, I am writing cos over sine, and in place of cosec x, I am writing 1 over sine. And then I will take LCM of the denominator. Now this is my denominator. So if I take LCM, it will be 1 minus cos x over sine x. Now what do you think? What should I do after this? Can you think of something? All of you know when we change division sign into multiplication, the fraction get inverse. So what I will do, I will write sin x multiply by sin x over 1 minus cos x, right? And now this will multiply. It will become sin square x. Now sin square x again I can replace by the identity I have just shown you up here, right? Which is 1 minus cos square theta. So I will use it here, and then it will become 1 minus cos square x. Now what does it remind you? Do you remember a square minus b square? Earlier in class 8 you have done. So 1 can be written as 1 square. So what it reminds me, I can use here 1 plus cos x, 1 minus cos x, because a square minus b square is equals to a plus b and a minus b, right? So now 1 minus cos x will cancel out, and I will be left here with 1 plus cos x, which is equals to right hand side. So this identity is proven. Let's take another example. Now this is question number 14. In question number 14, again I will take left hand side. Don't think I'm taking every time left hand side, because whatever sides you think is little difficult, complex, which can be simplified, you better start with this, because if you will start with simple thing towards complex, it will not be easy to prove it. It's not impossible, but it will take longer. So now what I'm doing here, I am writing here as sine square x power 2. So I'm changing this left hand side into the form of a square minus b square. Right? You got it? So now a square minus b square is a plus b minus b. So now my a here is sine square x and my b here is cos square x. So now it will take the shape or form of a plus b, a minus b. And we know that sine square x plus cos square x is equals to 1. This is an identity. So now I am left with sine square x minus cos square x, which is equals to right hand side. So I have proven this identity. Let's take question 16 now. Now if I take left hand side, what do you think, what should I do? Can I factorize here? If you see left hand side, can I factorize? So what is common? Sine square x. So if I take sine square x common, I will be left with 1 plus tan square x. Now what do I do? In place of tan square x, I can write, yes, cos square x over sine square x, which is an identity. But what I am doing here, I am using another identity. 1 plus tan square x is equals to sec square x. So you can do both in both ways, whatever comes in your mind at that time. So sec square x can be written as 1 over cos square x. So it will become sine square x over cos square x, which is tan square x, right? So it is equals to right hand side, so it has proven. Let's take question 18 now of the same exercise 11.1. Again I am taking left hand side. Now in place of tan square x, I can write sine square x over cos square x here. And in place of 1 plus tan square x, I can write what? Sec square x, which I have just applied in the previous question. Right? Now in the numerator, I will take LCM here. So it will become this. Okay? And in place of sec square x, what can I write? Do you remember the identity? Yes, 1 over cos square x. Again, I told you when we change division sign into multiplication, the fraction in the denominator will get inverse. So what it will become? Numerator is same as it is. This one will become cos square x over 1, which is here. And this will cancel out. So I am left with 1 minus sine square x. So identity is proven, which is equals to right hand side. Let's see another example here. Number 21. So number 21, I will take again left hand side, which looks complicated to me. So what do you think? What should we do? We should take LCM here, right? So I have taken LCM, and because the denominator is reminding me the form of a plus b, a minus b, a plus b, because they are same but the sign is different. So I am changing it into a square minus b square form. So it is this square minus this square. Agree? So now I am taking Of course, cross multiplication here. When we are taking LCM, we know how to go about it, because there is some knowledge is required, or you should know that thing before coming to this stage. So I am assuming that you know how to take LCM here. If you think you need explanation on it, please let me know through email, and I will explain this concept also. Right now I am assuming that you know it. So now I am opening the or removing the bracket, right? And my denominator will be tan square x, because we know the identity 1 plus tan square x equals to sec square x. So in place of sec square x minus 1, I am writing tan square x, right? Because if I bring it here, if I take 1 over there, so it will become sec square x minus 1 equals to tan square x. So now this sign x minus and plus cancelled out here. So I'm left with 2 sin x cos sec x. And in place of tan square x, I'm writing sin square x over cos square x. What do you think what you should do now? Can you put another identity, something here? Yes, sec x. In place of sec x, you can write 1 over cos x. And this division sign will change into, right now I have written as it is division, and I'm writing it as it is, but now I will change it into multiplication, and this will get inverse or flip. Right? So now this multiply by this over this is getting inverse, and then I will cancel 1 of cos with this, 1 of sine with this, so I am left with 1 cos and 1 sine, which is equals to cot x. So I got right hand side, which is 2 cot x, so identity has proven. Now the last identity for today's video, which is number 23. In number 23, again I am taking left hand side. So what comes in your mind? You see there are 2 sec, and we have just solved in few previous cases. When it is sec, we can write 1 over cos. So in place of sec b, I can write 1 over cos b, and in place of sec a, I can write 1 over cos a. And then I will take LCM here and LCM here. So it will become this, right? So again I will do the same thing. I will change this division sign into multiplication, and this denominator will get inverse in the next step. Fine. So now cos a multiplied by cos b or cos b multiplied by cos a is the same thing. So I'm cancelling this numerator with this numerator with this denominator, and I'm left with cos a over cos b. Now cos a over cos b can be written as cos a multiplied by 1 over cos b, and 1 over cos b is equals to sec b. So identity is proven. We have gotten right hand side. So thank you very much for watching this video. I hope you would have learned something. If yes, do like the video and do subscribe it. You will get my all new uploaded videos, which will be consisting of ADMAS questions, various question and concept, not only questions, concepts as well. If you have any particular question in mind, you can email me through my email address, which is mentioned in the description. Thank you very much.